guys, I'm making a video for you to help you get ready for the embedded assessment tomorrow. So there's just a couple real quick questions that I was going to go over for you that will help you in preparing for the embedded assessment tomorrow that will be graded for accuracy. So if you're looking at this, one of the things that they'll probably ask you to do on the embedded assessment tomorrow is to complete a table. So this shouldn't be, that's not what we meant to do. Let's go back up here. Shouldn't be too difficult. Let's see. Keep going down there. So you know here that the total of the tablet classic 75 plus whatever this is has to be 117. So if I take 117 and I subtract 75, that gives me 42. So right here in this column, I'll change I had to put in 42. So here again, the tablet minis, they gave me the total is 158. So I know that whatever this 16 gigabit tablet mini is, plus 63 gives me 158. So if I take 158 minus 63, I get 95. So this right here, when I fill it in, is 95. And then over here, I know to get this total right here in this cell, I would need to add 42 plus 63. So 42 plus 63 is 105. And then finally, to get this final total, 170 plus 105 is 275. But also if you take 117 plus 158, you get 275. So you should be able to go either way, and your total should be the same, and it is. And my total here is 275. Okay, so now I completed the table by putting in those numbers. So it says if a tablet is chosen at random, find the probability the tablet has 32 gigabytes. So if I look here, the total number of 32 gigabyte tablets is 105. It's right here. And I'm looking over the entire number of tablets that I have is 275. So in this case, this probability would be 105 over 275, which reduces to 21/55. So I would write in there, this answer is 21/55. Okay. So I could just put the next one says the probability the tablet is a mini tablet with 32 gigabytes. So it has to be a mini and it has to have 32 gigabytes. So that would be 63 tablets are minis with 32 gigabytes. And again, I have 275 tablets total. So this answer would be 63 275. And that doesn't reduce, so we'll just leave it like that. So the next question says a tablet that is not a tablet mini. So if I wanted to write that in probability notation, I would say mini, but then I would have to put that little C at the top, because that little C at the top indicates not. So I just want to show you that real quick. So if I put this in here with the little C at the top, that would mean right here, the probability M with the little c would mean a tablet that is not a mini, if M stands for mini. So not a mini. So there are 158 tablets that are minis, and there are 117 tablets that are not minis, that are classics. So in this case, if I wanted the tablet that's not minis, that would be 117 out of 275, because those are classics. not minis. And then D says the tablet is a tablet classic or has 32 gigabytes. So I would need all the tablet classics, which is 117, and then the tablet minis that are 32 gigabytes, which is 63 of them. So this would be, in probability notation, I could write that as the probability that it is a classic, C for classic, or has 32 gigabytes. So classic or 32, and that would be, in this case, I would have 117 plus 63 over 275. And notice I only counted these 32 gigabyte tablets once. I counted them once in the tablet classics, and then I just added these other 32 gigabytes. So you want to make sure you only count these 42 one time. And so if I put that in my calculator, I get 180 over 275. And 180 over 275 reduces to 36/55. So this would be 180 over 275, which reduces to 36/55. Okay, so most of you know how to do that problem. This is a problem where some of you had struggled a little. So it says a vehicle is selected at random from a city. The probability that it is an SUV is 0.28. The probability that it is a hybrid is 0.22. The probability that it is both a hybrid and an SUV is 0.04. Draw a Venn diagram. So this is where some of you, if you had comments on your page 593 that you returned, that you need to look at the Venn diagram stuff, here's where you really need to pay attention. So I'm going to go over here real quick and draw a Venn diagram with this information. Okay? All right. So if I'm looking at this Venn diagram that I'm going to draw, the thing that I want to make sure of, so here's my rectangle. Whoop. A little bit rough, sorry. Okay, so here's my outside rectangle, and I'm going to draw my two circles. With the part that overlaps. And I'm going to use S for SUV in this case, and I'll use H for hybrid. So the one thing that I want to make sure that I do not do is if I go back and I look at this, it says the probability that it is an SUV is 0.28. The most common mistake is to come in here for S and put 0.28 right here. But that would be wrong for this reason. Okay? It says the probability of both. If you go back to the problem, it says the probability of both is 0.04. Probability that it's both a hybrid and an SUV is 0.04. So most of you know in your Venn diagram, that means that that goes right in the center. So in the center, I would have 0.04. But if I put 0.28 right here, there's a problem because all of S, everything inside of S is 0.28, not just this part. So to get this part right here, I would have to take 0.28 minus 0.04, and that's 0.24. So that's how you figure out what goes right here. You have to subtract that out so that this entire probability of getting an SUV, because S stands for SUV, is 0.28. So that's my 0.24, this is my 0.04. The same thing for the hybrids. So if you look back here, it says the probability of getting a hybrid is 0.22. But that means the entire H probability is 0.22, and these 0.04 people are inside of this circle of H. So to get this part out here, it's not 0.22, it's 0.22 minus 0.04, which is 0.18. Okay, so that's 0.18 right there. And so then remember, all of your probabilities inside your Venn diagram have to add to 1. So you got to figure out what would be outside here. So if you take 0.24 plus 0.04 plus 0.18, you get 0.36. And if you take 1 minus 0.3, or 0.18, not 0.08, I'm sorry. You take 0.24 plus 0.04 plus 0.18, you get 0.46. And then if you take 1 minus 0.46, out here you would then have 0.54, because all of these probabilities inside here need to add to 1. See if I can make this look more like a point here. Okay, so now that I have the correct Venn diagram, I can use that to solve for these probabilities. So it says a vehicle is picked at random, find the probability it is a hybrid or an SUV. So in probability notation, that's asking me for hybrid or S for SUV. So if I come back here, probability that is a hybrid or an SUV, okay? My options are to take all three of these numbers here, 0.24, 0.04, and 0.18, and add them together and get 0.46. Point 4, 6. Or I could use the addition rule. So the addition rule says that the probability of A or B, or in this case H or S, equals the probability of H plus the probability of S minus the probability of both. And that's so probability of H and S. And that's so in the Venn diagram that you don't count these people in here more than once. Because if you count them with S and you count them with H, you would have double counted them because they're in the circle of S and they're in the circle of H. So if I come back here and I put that in, so the probability of H in my information up here was 0.22. I put that in over here, 0.22. And the probability of S was 0.28, so 0.28, minus the probability of both, which is 0.04. And in that case, I should get the exact same thing. So if you take 0.22 plus 0.28 minus 0.04, you get 0.46, which is the same thing we got when we added 0.24, 0.04, and 0.18 from our Venn diagram. Okay. So the next one says that is neither a hybrid nor an SUV. So you look at your Venn diagram, it's not either one. So it's not inside the circle of hybrid, it's not going to be anything that's inside the circle of an SUV, so that probability will be 0.54 based on my Venn diagram. And then a hybrid that is not an SUV. So again, I'm going to look at my Venn diagram. So I want a hybrid that's not an SUV. So everything inside this circle is a hybrid, but the people inside here, they're also part of the SUV group. So a hybrid that's not an SUV would just be this 0.18 right there. So that probability would be, answer there would be 0.18, okay? All right, so now the next one says you have a set of 20 cards, 10 red cards labeled 1 to 10, 10 blue cards labeled 1 to 10. Let R be the event a card is red and B be the event the card is blue. Are R and B mutually exclusive? Mutually exclusive means that they cannot occur at the same time. So mutually exclusive events do not occur at the same time. And we know that means that the probability of A and B, when you have mutually exclusive events, probability of A and B for mutually exclusive events will be equal to 0 because they're events that cannot occur at the same time. So when it says let R be the event the card is red and let B be the event the card is blue, are R and B mutually exclusive events? The answer to this question would be yes, because a card is not going to be both red and blue at the same time. Let R be the event the card is red and T be the event the card is a 10. Are R and T mutually exclusive events? In this case, your answer is no, because you can have a red card that is also a 10. 10 red cards labeled 1 to 10. All right, so the addition rule real quick. One more time. If you have events that are not mutually exclusive, which means there's going to be some overlap, you want to make sure that you don't double count the overlapping parts. So you would have probability of A plus probability of B minus the probability of both. And so okay, whoop. So let me make sure you can see this minus sign a little bit better. So addition rule, probability A or B equals probability of A plus probability of B minus the probability of both. If they are mutually exclusive events, that means they cannot occur at the same time, and so there's a special addition rule for that because the probability of A and B will be 0. So if and only if they're mutually exclusive, the probability of A or B would just be equal to the probability of A plus the probability of B, because the probability of both happening at the same time, this is 0. All right, thanks guys.